is the RISC-V open hours. So the idea here is it's a bi-weekly informal meetup so that we can interact in real time instead of just over email. And the call for participation is open. You don't have to have any prepared talks or slides. You can just jump in with any topics you want to talk about. We're mainly focused on RISC-V software and RISC-V dev boards, but anything RISC-V is on topic for this. And we do it every 2 weeks, and we flip between time zones. So this is the one that is good for the European evening, early evening, and the morning in the US. I'm on the West Coast in Portland, Oregon. And then we do the other one in the evening in the Americas, which is the following morning in Asia. So that one will be coming up on June 8th, which is the one that is good for the Asia time zone. And usually several of the other RISC-V ambassadors like Uefi and Weiwu will join for that one, and Akira also. So then the next one in this time zone will be on June 29th, so about a month from now. And let's go to the next one. I just have a few slides to get started off with here. So I think about 2 weeks ago was the RISC-V week in Paris, and the videos are up now from that. So I listed a few there that I thought would be of interest. So Mark is the CTO of RISC-V International, so he gave a State of the Union, and then him and Philip is the chair of the Software Horizontal Committee, which is kind of the overall group that's steering software efforts at RISC-V International. And he gave a talk about the RISC-V, kind of 2 talks about the RISC-V software ecosystem. And then there was also a talk about a new spec that's in development for an IO MMU. So those were, I think there was maybe 10 talks total. So that was a couple of the ones I thought were interesting. Let's see, oops. And there's still all the talks up from the RISC-V Summit back in December. So if you haven't seen those, I recommend checking those out too. I think there's, something like 93 videos. So there's a lot from the Summit back in December. And if you've not joined this session before, just some things to know about. So RISC-V International is the place that hosts the RISC-V specifications and helps develop them. And individuals and nonprofits can join free of cost. So if you aren't a member of RISC-V International or part of a member organization, you can go and sign up as yourself, and it's free to do that. And then once you sign up, there's a technical wiki landing page that has a lot of great links to all the different resources within RISC-V International. So maybe I should resize this window so it doesn't get clipped by Zoom here. So there's lots of good links on here. So I recommend always checking this out if you're trying to find out where something is within RISC-V International. And let's see what else. And then another thing to be aware of is that there are mailing lists. So if you are a member, you can join the mailing lists and participate on them. But the archives for all the mailing lists are also public. So for all the different working groups and special interest groups, there's usually a mailing list for them. So depending on your areas of interest, you can sign up for those mailing lists. And then there are also meetings. A lot of groups have bi-weekly or monthly meetings, and you can find the technical meetings calendar. So let's click on that right there and take a look at what's happening currently. So there's meetings on most days. So the ones I usually try and attend are the let's see where it is. It's called the Software Horizontal Steering Committee, or HSC, and that's kind of the overall software meeting. So this is coming up on June 2nd. So Philip's the chair of this, and it kind of all the different efforts related to software will report in this meeting. So if you're just looking for one meeting to attend, this is a good one. It happens once a month. And if you aren't able to attend, and Philip always sends out to the mailing list the slides and notes about the meeting as well. Some of the other ones are the platform spec. So the RISC-V platform spec is in development, and they have meetings every other week on Mondays. So that's another one that I try to attend. So yeah, check out the calendar and see what was of interest to you. And if you become a member, then you can start attending those. And let's see here. And I just wanted to go over this past Sunday, Linux 5.18 was released, which is the latest version of Linux, the Linux kernel. And that happens about every 2 months, like, well, 2.5 months that we have a new version of Linux. So this is the latest one, and there was a few RISC-V things in there. One is that there's now a page table model that supports 128 petabytes of virtual address space. So probably not of practical use to most people, but it's good to see that we now have that capability going forward for the future. Something that's probably of more practical use to people is Atish has a patch set that improves the ability to use the utility perf on RISC-V. So prior to this, the things you could do with perf, which is a very powerful performance monitoring tool, was pretty limited. And now it kind of has the same capabilities that you'd find in perf on x86 and in ARM64. So that's quite nice. Nuke also added CPU idle support. So using the hard state management extension in SBI, you can now have hearts be idled and suspended to save power. And another thing that was interesting is as the RISC-V ISA strings grow, and we have last year we had 45 new extensions added, I believe. It was becoming difficult for the Linux kernel to correctly parse those ISA strings, so all the different characters for those extensions, and especially now we have extensions that have multiple letters in them. So Atish had a patch set that fixed all that, and now the kernel can correctly parse all the current RISC-V extensions. So this, like for example, in device tree, you might have listed what extensions the processor supports, and until this patch, it was not able to correctly parse some of the newer ones. And one of the things I wanted to bring up here was probably some of you have heard of the All-Winner D1, which is the first RISC-V SoC that can run Linux that is in mass production. And there's been an effort since maybe middle of last year to try and get that supported by mainline Linux kernel. And Heiko has been working on this for a while now. And the patch series to support the page-based memory types looks like it's going to be in Linux 5.19, which is the next version of Linux, which I guess would be towards the end of summer, about 2.5 months from now, probably. So this implements the official supervisor mode page-based memory types extension, which was part of the privilege spec back in December that was ratified. And this allows you to declare memory pages as non-cacheable or IO memory. So this is useful for SoCs like the All-Winner D1 that have peripherals that are not coherent to the CPU cache that we need to manage when we do DMA with them. However, the CPU core from T-Head that was in the D1 had a custom page table entry format that was different than what's in the official extension. So this patch from Heiko accounts for both the official extension and that variant that'll be adding support. So this is pretty good news, because when this first kind of came up towards the end of last summer, it was very unclear if it was going to be possible to support this variant that the D1 has in mainline Linux, and it looks like now we'll be able to do that. There's still other work that needs to be done for the D1 to run mainline, but this was one of the big pieces of that. And then just a couple other things I had seen on the mailing list is, one of the other big extensions that was ratified at the end of December was the vector extension, which is pretty exciting capability to do variable length vector instructions on RISC-V. and this is to add support into the Linux kernel for that. And I haven't seen too much activity on this patch series, but now that it's ratified, at least hopefully it can get added to Linux. And then there was also some optimization for interprocessor interrupts from a Anoop that's on the mail list as well. So that's kind of the end of the slides I put together for today. So did anyone have anything else they wanted to like chat about with the Linux kernel or any other topics?
I had a couple questions.
Sure.
Did all of the patches for the unmatched land in 5.17, or are those still TBD?
Let's take a look.
Because I'm still having a heck of a time getting mine to work.
The
Like
running upstream on the unmatched.
Running anything other than open embedded or Haiku. Haiku works fine, but trying to get some of the other stuff, like I would love to get Debian running on it, and I realize I probably need to make some kernels, but I don't know what patches I need, and that's been the problem.
Just to get the like the mainline kernel to boot on the unmatched.
I mean, yeah. I mean, I've also been trying to like figure out how to get the kernel out of the open embedded build into a Debian package so that I could try that, and I haven't had much luck there either. So yeah, it's been a challenge.
Well, he doesn't usually join this, but one of the good people to ask is David Narakbanov, or David LT. He's actually, do you do IRC at all?
I can.
Because
it's been a while.
Is a good place to ask about that. So David, he does Fedora RISC-V, but in addition to that, he also used to work at Sci5, and he did the SDK, kind of managed the SDK releases. So like the
Got it.
Freedom U SDK, I think it was called.
Right.
So the Yocto based one, the open embedded based one. So he's very knowledgeable about those sorts of things, and he goes by.
I think he and I have actually passed some messages back and forth to each other as I've been trying to figure things out. But yeah, that's cool. Okay.
Well, let me drop it. Yeah. So David LT on OFTC, Fedora, RISC-V. He's quite knowledgeable about that.
Cool.
You know, I don't have an unmatched, so I guess I kind of assume that it just worked because I see a lot of people doing upstream development on the unmatched. So I assumed it just worked, but that's,
yeah, I mean,
that is a good question.
Yeah, I mean, I've been looking around and like trying to get stuff. So like one of the things that I spent a couple months trying to get Grub working, and I sort of have Grub working, starting with all of the patches that Uefi and a bunch of other folks had worked on for like the D1. I was able to get all that stuff over and working, but the problem I'm running into is like I can only get that to boot the open embedded stuff, or the like I said, Haiku. Like that's where I can't even get FreeBSD to boot, and I know that's supposed to support it as well. So I'm just trying to figure out what I need to do.
Oh, sorry, I was wrong. It's not OFTC, it's Libera Chat.
Yep.
Which is the thing that replaced a lot of the free node things. So it's
right.
Actually, it's Fedora RISC-V on Libera Chat. But Jim had posted a link in there to Carlos, who's one of the other RISC-V ambassadors. He looks like he has a guide on here, which is from 3 months ago.
Okay, I know Carlos, so I can.
He's also really active on Twitter too, so
yeah,
I'm sure you could also tweet at him.
Yep.
But let's see what he was doing here. But you had mentioned Grub, which is a little bit different, I think, than what a lot of people are doing, because I think they
Yeah,
just
a lot of people are just going U-boot and then throw a kernel at it and kind of go from there. And kind of what I'm trying to go for is like seeing if there can be, because I know this was something that you guys talked about in the last Asia Pacific open hours, is the whole, hey, we need an OS, and I completely agree. So I'm trying to see if I can spend some time to get to the point where we have, okay, here is a system of boot stuff that is relatively standardized, because I've been fighting this this war for a very long time on the ARM ecosystem.
yeah.
And it's been an uphill battle that hasn't been going well. And part of the reason for that is because a lot of the standards don't necessarily make sense. Like everybody keeps pushing for ACPI, but the biggest problem with ACPI is that it makes everything look like a 486. And that just doesn't work. There was a big, there's some hardware available in that space, specifically the solid run honeycomb. And there's one person who's been trying to get all of that work with server ready and like all of the standard procedures for getting it booting and running and all of that fun stuff. And that's what the operating systems claim is the holdup, is that we want everything to be standardized. And so it's just trying to get all the bits and pieces going. I have Grub running, like that's great. But the problem that I'm running into is like it comes up, but like the kernels that come out of even the Fedora build process for their RISC-V images fail to boot. They'll get about halfway and then they panic, usually complaining about timers, or it gets into the initial RAM disk and then falls over. They either panic or they just stop, and there's absolutely no insight as to what's going on, which is why I haven't really been focusing on the Fedora stuff, because systemd. So with systemd, all of the messages are eaten by journal control and you can't see them on the serial output. Whereas if you're using the basic init RD stuff, you can actually see the errors. It's these are all problems that like don't exist on x86 because they were solved 20 years ago.
Yeah, but Heinrich Schuchert here from Canonical. So good morning.
Morning.
Ubuntu and SUSE are both booting via grub on an unmatched board. Did you try to boot one of these kernels? And so you have to find out if your grub is wrong or whether your kernel is wrong. And so can't you start from one of those distros and just replace the kernel by your kernel and see whether it's, you get it? I mean, Ubuntu is booting with the kernel that we provide via grub. If you use the description here, how to use the server install image, then just install your kernel afterwards, see if the kernel has a problem.
Yeah. The last time I tried this, it didn't work for me either, so I will have to go back and try it again. It's been a while. It was not jammy when I tried it, so I'll have to give it a shot.
So what is new here is, so we used to have pre-installed images. So these was run from the SD card, which is very, very slow.
Yep.
And this installer image is if you have an NVMe drive installed.
Right, which I do. Okay, cool.
This is nice. It's much more like a normal computer, looking at the instructions here.
Yeah, and that I mean, that's kind of been the goal, is like get to that point. So I'm happy that we've gotten that far. Now it's just a matter of me figuring out what's up. So
this was now new with 2204 release that we provide this server install.
Right.
And Heinrich, you joined Canonical, was it last year?
Yes, in July.
Okay, awesome.
Okay.
And my focus is on RISC-V.
Yeah, it's great to see that there's like, and this is, like I said, official, right? It's not like a remix, right? It's official from Ubuntu.
this is an official install image, yes.
Okay.
So, and of course, we have also daily builds for it. We have also for kinetics, the next release, daily builds. So this is at least going to stay as long as it makes sense. Well, I mean, the installer image makes sense as it runs with QEMU anyway. The problem is, of course, unmatched board isn't produced anymore. It will be obsolete in a year or two. And this is why we are currently also looking into providing pre-installed images for other boards. I mean, we have those NESA boards, those Vision 5 boards. It would be great if the distros would also provide pre-installed images for those.
I think the right answer here is to try and come up with, like, because this is the thing that I've been working a lot with in the ARM space as well. The same problem exists. People make boards, they don't necessarily have the software support. You know, the comment that was made in the last meeting was like the board manufacturers just need to support an operating system. It's like, it's not that simple. I wish it were.
It's very simple. I mean, ARM has a qualification program, and
which no hardware supports.
Which
like no hardware passes that qualification program. That's the problem.
No, dozens of boards have passed it, including the Raspberry Pi, including many NXP boards, and on most ARM v8 boards, you simply boot via U-boot grub, and it simply works out of the box with a Debian installer image.
I mean, that has been very far from my experience on most boards. Yes, the Raspberry Pi does support it. That was a 5-year community effort to get that working.
Yeah, but U-boot supports the EBBR, and with EBBR, you have enough services available to run grub and to boot a kernel. Agreed.
Yeah, absolutely. And like that's kind of what I want to try and focus on, is getting to the point of like, okay, we've got a U-boot. Can we get enough of U-boot working in the various platforms to get this up and running? Like the problem that I'm running into with the unmatched is it appears to be something related to the device tree. And it's very difficult to figure out what the issue is there. Like what I'm seeing is like the kernel messages I'm seeing is like, I can't find any timers. And I'm like, okay, that's a problem.
But then the question is, which device tree do you load before you load grub?
Right. Yeah, exactly. Like, and that's the sort of stuff that if we can, that's where I'd like to see like the BSPs supporting of like, okay, we get to the point where we have a U-boot that can get us to an EFI grub and then move forward from there.
So currently in the Ubuntu image, we use the device tree command and then call, and we have added a patch to grub so that it calls back into U-boot for device tree fix-ups.
Right. And I think that's the problem that I'm running into right now is like, I'm passing the correct device tree into grub and then grub apparently ignores it. Like it uses it, but it doesn't pass it on to the operating system is my point. So
if you use a device tree command, it will load it, but it will not do the fix-ups. Yeah. So if you want to fix ups, you need a grub which has patches for it, and
yeah. and that stuff's not upstream, and now we're getting to the frustrating part of like where are those patches, what patches need to be applied, what are the fix-ups? Yeah, totally. Okay.
Is there Heinrich, is there a mailing list thread with patches that are needed for RISC-V for grub?
The patches are in the mailing list hidden somewhere for sure.
Yeah.
But the first question is, how does this fix-up work? And I've set up a repo where at some there's a chat.
Oh, okay.
Awesome. So there I put the specifications for the protocol that we have implemented into U-boot, and you will find also grub patches there, which were valid at some point in the time.
Right. Yeah. And yeah, and you know, like.
And I've sent those patches also upstream. They're also on the mailing list, and The worry that Peter Jones had was that the device tree command is switched off if you are booting via shim. And so he was not sure whether he would like such a patch. So he was asking, okay, what will you do if you have at one time have secure boot?
Yeah. And I think the answer there is why don't we cross that bridge when we get to it?
And the real problem behind is that device trees aren't signed. So you cannot verify if maybe somebody sent you a device tree with voltages which will crash, which will ruin your board forever.
Yeah. I mean, I probably the right answer here is that the device tree probably needs to be in a signed U-boot that can then be passed all the way up the chain, because at least there you can go, this device tree that is in ROM has been signed and like we're okay with that. But yeah, like these are these are all complicated problems.
Okay, but at least you have now a starting point to understand how device tree fix ups is. And the next thing is, if you really want to understand what grub is doing, you can set the debug parameter in the command line, and that debug you will get a lot more debug messages telling you, okay, which protocol was loaded and what it's doing. And if you call the kernel, you should call it with Uefi is debug, so that you also get more messages for Uefi out of the kernel.
Yeah. Okay. Yeah, like I said, like the two that I've gotten the farthest to boot on is I have, so the Fedora stuff gets the farthest. Like it actually starts running stuff in the init ramfs and then stops. And that's frustrating because their init ramfs contains systemd. So like you can't see the messages anymore, which is unfortunate. There's probably a command line option that I can throw somewhere to get them, but I don't know what it is. And then the kernel that I was trying from Debian would complain about timers. So it obviously wasn't new enough, and I've been trying to figure out how to get that stuff. But like, it's one of those things of like, no, just add a kernel isn't necessarily easy either, because you need all the modules that the downstream operating system expects there to be, instead of just passing it a monolithic kernel, which is what the open embedded stuff is doing. So figuring out all of the patches and then putting that into the kernel make process, like it's rough, as I'm sure you know. So cool. I will look into all of this and maybe I can get some answers. I appreciate the pointers. Thank you very much.
So this fix-up protocol, this is kind of what's needed for EVBR to work on U-boot, is that right?
This fix-up protocol is only needed if grub is loading the device tree. If you load the device tree in U-boot, everything is fine. But you have to pick a device tree that matches your kernel. The real problem is that often device trees from the Linux kernel are neither up compatible, not downstream compatible.
Yeah.
And this is the real pain. And this would be like if the ACPI tables that were in your laptop wouldn't be able to boot a new Linux because they have changed in the meantime.
Yeah. And yeah, and this is the thing that I find entertaining is everybody sits here and goes, you know, this should be boring. This all just works on x86. And my response to that is, you're not looking close enough, because it doesn't. There's problems like this all the time on new processors, new motherboards, new chipsets. It's just that the space is large enough that it's normally not a big deal. I mean, it's taken what, 10 years to get some of the ACPI fixes for ASUS motherboards because of their downstream BIOS that has problems. And yeah, this is it's all hard and complicated, and a lot of it gets swept underneath the rug. And I'm trying very hard to put together enough information so that we can try and get it so that we're not all just pointing fingers at each other, because this didn't work at ARM, and I really don't want to have a repeat of this inside of the RISC-V ecosystem. It's been really frustrating with everyone going, with kernel maintainers going, you need to follow the spec, hardware maintainers going, we do follow the spec, what are you talking about? And the integrator and the hardware, I take that back. The integrator is going, we are following the spec as best as we can. I don't understand what the problem is. And the hardware developer is going, if we swallow the spec, then there's no reason for us to make the hardware, because what's our value add?
Okay.
Well, Heinrich, what do you think about the current draft of the platform spec? Do you think that will help with some of these things once things are complying with that?
I was involved in the discussions last year. I must admit that this year I didn't follow up, and but it's really, at that time it was really putting or saying they would simply want to follow the EBBR, so just follow the trampled road.
Yeah. So I mean, Drew, yes, like the vision on the platform specs, as far as I'm concerned, is there. Like what they want to do makes sense. The problem becomes, it's gonna take 5 to 10 years for the hardware to catch up with the platform specs at a minimum. So in the meantime, we're still going to have a situation much like we have on the ARM side, where the hardware that everybody has is Raspberry Pis, and the software is all being written for Ampere servers that follow the specifications. And Ampere can dump tens of millions of dollars into getting everything to follow the specs and doing regular firmware updates and all that fun stuff. We hope, like this is what caused Centrique to fail. This is what caused Cavium to go out of the market. Like all of this is related to this stuff. So it's hard. Just pointing at, like, this was one of the things that I brought up a lot in discussions at the summit last year, was that everybody keeps pointing at ARM and saying this was successful, and I'm going, no, it wasn't. Like retreading the same water does not necessarily make our life better. We need to come up with a better way.
Yeah, what we are really missing is something like Linaro, who really work on getting things fixed.
But even then, like I know a bunch of folks at Linaro, like they're just as frustrated because even they can't get fixes put in place. Like if you are a standards-based solution, then the answer is re-roll your silicon to support the standard. If you're not a standards-based solution, see M1 Max, you get kernel patches. Like, and this is what I don't want us to follow down the path of inside the RISC-V ecosystem. Like we need to be able to make all of this work, both at the cheap board level and at the really big server level. So yeah, OSA is going to be awesome. When will hardware support it? Like the conversations that I've had with the successor to the Unmatched will not have AIA. That is the first thing you need to support OSA. Nobody has AIA. So if we don't have that, then we're still in the same boat that we're at right now. Plus, you've got an entire ecosystem that's building stuff that's 32-bit only because that's all that fits in affordable FPGAs. And that's never going to have AIA.
Yeah, but that's not, OSA is 64-bit, that's it.
Yeah, I mean, but so we say that, and at the same time, like I remember 3 years ago when everybody was like, we're only supporting 64-bit in Linux, that's it. And yet there is a tremendous amount of RISC-V 32 in Linux because that's the hardware available, because you can get cheap FPGAs for it. So like that needs to be taken into consideration.
What part of AI? So with AIA, right, we have several different components of it, right? I mean, part of it is the message signal interrupts, right, for PCI Express. So you're saying that the next gen Sci5 cores don't have the APLIC?
They don't have any of that on their roadmap, from what I understand. They're going to keep using the same interrupt controller they currently have.
Okay. I mean, I guess the other side of it too is it's not ratified yet, right? So
Yeah, and like exactly, like I don't want to say that I'm like I don't want it to seem like I'm pointing the finger at Sci-Fi and saying this is their problem. It's not. Like there's a lot of stuff that has revolved around that. And yes, AIA it's a specification. It's not completely ratified. I think part of the reason why AIA isn't ratified yet is because nobody's built it in hardware. So it's a chicken and the egg scenario. And again, like there's gonna be a lot of boards in the market, like all of the stuff that's coming out of Allwinner, like the D1 stuff and things like that. They're not going to support AIA for a very long time. So the OS platform stuff is great, but its barrier to entry is very high right now. And like I said, it's probably going to be 5 to 10 years before we get hardware that's there. So we should probably try and come up with a solution that can support both and make a way where the amount of work that hardware manufacturers need to put in to get to the point where there is enough framework to put a Linux operating system on top of it makes way more sense than following EBBR, which every board manufacturer says they're compliant with and nobody's kernels works on. Like, you have entire projects like Armbian that are basically spinning custom kernels and custom bootloaders for massive amounts of hardware because what the hardware vendors say they match in EBBR doesn't match the reality of actually getting Linux to work on it.
well, isn't it also some of it's not? I mean, some of those boards, some of those SoCs don't have mainline support, right?
Correct.
And they might be on older kernels. I mean, the impression I have of like ARM System Ready, ARM System Ready IR, which is I think the thing that would apply to single board computers, is that like if your board were to support like mainline versions, then it seems like it would work with that. But I know a lot of single board computers are using SoCs that don't have upstream support, right?
Right.
So maybe that's part of it.
Yeah, so part of it is that, but like this is the chicken and the egg problem. So like the boards don't have mainline support because the manufacturers don't support mainline. And when the manufacturers try to submit patches to get into mainline, they're told you aren't following the standards, go re-roll your silicon.
Yeah, that's what the problem is in NESA board.
That does, you mean in Linux? Because I think it would be more just the vendor needing to write device drivers the correct way, right? Not
necessarily. So let's take the honeycomb for example. So the honeycomb is based on the Layerscape 2160A, which is according to NXP's website, system ready. Like it's SBBR, it's system ready, great, wonderful, and that is true as long as you don't want to use any of the networking USB PCI Express on it. So you can get a box up with a serial port and memory, and that's it. Like, because all of the rest of that stuff is not standards compliant. And the reason it is not standards compliant is because what the community wants from standards compliant, and the community being both the ARM standards and the Linux kernel, is give us pre-existing IP that already works, that meets the standards for PCI Express, and then everything shows up as a PCI Express device. NXP's answer to that is
the PCI Express implementation has quirks that
yes, every PCI Express implementation has quirks.
Or
like,
what the expectations are of like the PCI Express subsystem in the kernel. Doesn't work with that.
So what NXP is trying to do with the Layerscape line is that they have this programmable CERDES system that you can set it up so that you can, there's a ridiculous numbers of lanes coming out of that SOC that are part of the CERDES engine. And you can make some of them PCI Express, you can make some of them 10 gig Ethernet, you can make a 50 gig Ethernet, you can make 100 gig Ethernet. Like you can mix and match that. And that is also how the onboard NIC functions from Z. So the 1 gig NIC is also a SerDes lane. Great. That is not PCI Express. So when you put the system into ACPI standards mode, none of that stuff works because that's not part of the standard. Now, why did NXP do this? Well, because their customers wanted the flexibility of I want PCI Express or I want high-speed Ethernet. So putting an off-the-shelf PCI Express route in doesn't necessarily make sense. At the same time, look at the last 2 Sci-Fi boards that have come out. Those have standard PCI Express root IP, but they also require quirks and fixes. Even the PCI Express root IP that's in the Raspberry Pi 4 requires quirks and fixes. And it's only getting worse. Like the PCI Express 5 IP that's coming out on newer machines is got even more quirks and weirdnesses that are happening with it. Stuff isn't necessarily compatible between vendors. Like it's a mess. But everybody keeps holding up PCI Express as the standard, and it's like, yes, but. So the hardware
Isn't that usually the
manufacturers-
case though in Linux? I mean, the version I have in Linux is like a lot of the complexity in drivers is dealing with all these different idiosyncrasies from different vendors, right? Like,
yeah, agreed. So this goes back to the whole standards versus not standards thing. So an example, I have a Jetson Nano TX2 Nano in the other room. That is still running NVIDIA's BSP 4.9 kernel, and that's all it will ever run. There have been people trying to put patches into the Linux kernel for over 6 years to support the PCI Express quirks in that board. And the universal response, and people from Linaro too, and the universal response from the kernel community is, you made the hardware wrong. Go back and fix the hardware. Because it is a standards-based system. Whereas if you look at the M1 Mac, that gets kernel patches all the time because it is not a standards-based system. And so they will allow things for PCI Express quirks and all of that fun stuff. So it's a large impedance mismatch between the current teams. It's a lot of people pointing at the other people and saying it's your problem. And my goal here is to not repeat that. Like that is the ideal world that I want to live in.
It's a bit surprising to me because I mean, the impression I have, I mean, I've not really looked at PCI Express before in the kernel, but like typically it's like if the hardware exists, like they'll usually try and figure out a solution so that the hardware can be supported in the kernel. But that's interesting. What mailing lists are appropriate for the PCI Express stuff? Is it networking or some other?
No, it happens in the architecture mailing list. So for this, and the primary difference here is that in the ARM v7 world, it's the Wild West, and everybody hates it, which is why in the ARM v8 world massive changes were made, and they're like, we're only supporting the standard. And that's where all the problems comes in.
Okay. I guess it's kind of similar with RISC-V, where Palmer's trying to really only support things that have been ratified. So kind of a similar tension there.
And that's reasonable. I mean, the other part of it is like, from a specifications and a software standpoint, like only supporting ratified specifications, fully agree with. Like
it's a little bit different though, right? This is like I mean, I guess the D1 is really more like this, right? Because there's the RISC-V specifications, but this is more like the SoC vendor variants, right? Like what they implemented, right? Which
and this is where a lot of the tension comes in. So like this was the big lesson that I learned from the ARM ecosystem, is that the software teams and the specification teams are basically kind of all on the same page, and the hardware teams are kind of an afterthought. And that's the thing that we need to fix, because when I worked in a large organization where we wanted to buy a lot of ARM servers, and we went to the major manufacturers and we were like, why don't you make a standards compliant thing? Why don't you just take off the shelf ARM cores, off-the-shelf PCI Express, off-the-shelf memory controllers, slap it together with GIC v3 and call it a day. And the universal response from all of them was, because anybody can do that, what's our value add? So they need to be able to make differences in the hardware from their perspective in order to make it work. And we're seeing the same thing in the RISC-V hardware world right now. Like, a lot of things are the same, but a lot of things aren't either. Like, everybody's using the programmable interrupt controller from Sci-Fi because very kindly of them, they made it available under a BSD license, so it was broadly available on. But people make modifications to it.
Do you mean the IP, like the Verilog, or okay, or they're not Scala, I guess, or Chisel?
They made their interrupt controller available via Chisel, and AIA will supposedly be available under a liberal license as well. So like that's good news. And the only reason I say supposedly because it hasn't happened yet. So
well, with the interrupt controller, it's interesting you mentioned that, because I was actually asking Samuel yesterday and also Heiko about like the other things that are needed for the D1 to be supported by mainline. And one of the things was the interrupt controller, because it is based on, I guess, what Sci-Fi did, but with some unique things, right? So which is kind of what you're talking about here, where like we only have like a couple SOCs, but even with the few SOCs that we have, we see that the interrupt controllers are like kind of similar. There's still some differences that need to be worked out.
And even on top of that, like the thing that everyone keeps saying, and when I say everyone, like this is the talking points of RISC-V International, this is the talking points of ARM, general purpose computing is dead. Everything is moving towards application specific computing. And what that means is we're putting more application specific IP blocks inside of SOCs. So those are obviously not going to be connected via PCI Express like everybody assumes they will be. They're usually a cache coherent connection into the rest of the system in the SOC. This is where your neural networking processors, your video accelerators, your various other neural networking stuff, your ML accelerators, like all of that stuff kinds of comes in here. And it's still the Wild West. It is way too expensive to make those PCI Express devices, because the entry point for PCI Express is $50 million NRE just to get access to the Verilog that can do an implementation on an FPGA, never mind in silicon. And then there's recurring royalties that you have to pay on top of that, and it can't be open. So people are going to skip a lot of that to just plug it into TileLink and AXI and things like that on the existing SOCs. And that's fine. We just need to keep that in mind and not blind ourselves to a ACPI, everything is on a PCI Express bus and everything follows the PCI Express standard, because that's not going to happen.
Are any of those, how many of those like are encumbered by like needing to have like a proprietary standard, or are some of those like are some of those free to use, or needs to like be a member?
So the only ones that are free to use are basically AXI and TileLink. Everything else requires royalties. Like even if you want to use PCI Express, like I said, the cheapest PCI Express IP I've been able to find has been $50 million NRE upfront just to get access to it, and it's not open.
Wow. And there's a new one too, right? CXL, I've been seeing getting mentioned.
Yes, so CXL is built on top of PCI Express, so you still have that $50 million NRE just to get, and CXL requires PCI Express 4, that's closer to $80 million NRE in order to get access to Verilog blocks that you can begin with. So yeah, it's super expensive, and this is, a lot of this is documented on the boards that Sci-Fi has released up until this point. Like people were very upset when both the Unmatched and the Unleashed came out, because they were like, hey, these bootloaders aren't completely open source. And they're like, yeah, you're right. And then people got really grumpy when the open source versions were like, okay, cool, we're going to go take, we're going to write this magic number into this register, and then the memory controller's initialized. And everybody's like, well, what does that magic number do? Like, where's the documentation for this? It's like, we literally can't share it with you because this is part of the proprietary IP that we bought for the DDR memory controller, or the proprietary IP we bought for the PCI Express controller. Just know that you write this magic number into this register and it's initialized, and now we can move on with U-boot.
Well, so the previous Sci-Fi board, the Unleashed, was pretty good in that regard, right? Because I think they even had the zero-stage bootloader open source, right?
So there was a lot of pushback to get the zero-stage bootloader up and available. Like, that was the thing. Originally, the ZSBL was not available, and there was a huge outrage for that. And then they worked with their IP partners to be like, okay, what can we do? And then what came out is exactly what I described, of like, magic number goes into a register, like, here's the commented assembly code. And everybody was like, how is this? There was still more pushback of like, how is this open source? Like, how are we supposed to know what this does? And the response from there was, this is the best we can do.
Well, this seemed to be really nice, right? Because I believe, so this one even uses U-boot SPL, right, for as the initial bootloader. That and I think the DDR timing stuff ends up just being like some hex, some like binary information in a header, right? Which is like pretty good, right? Like,
I agree. Like, I think the work they did on that is absolutely fantastic. But it's an expectation thing. Like, and that's part of what needs to be, that's part of the challenge is coming up with that. Initially, it wasn't the U-boot SPL. Later, somebody ported U-boot SPL to it, but
well, that's kind of a relevant thing, I think, for a lot of these RISC-V or any SoC, right? Is like, the ideal thing is to have U-boot SPL that does the DDR initialization and all that. And oftentimes it starts off as a vendor one, right? So I think initially Sci-Fi had the FSBO, I think, which is the first stage. And then that was eventually replaced with U-boot SPL, which is ideal, right? Like, that's like the best practice, right? Is to have U-boot
I agree.
SPL.
Yes.
But like, a lot of them, like, they don't get to that point because well, it takes a fair amount of work, and then I guess there's also the concern about like the IP issues. So that's pretty interesting that Sci-Fi was able to negotiate that. You know, the few SoC vendors that I've dealt with were didn't feel like they were in a position to dictate things like that. So that's pretty
like cool. It was a multi-month process to get and this, I think the only reason why this worked fairly well was because at the time, you have to remember the Unleashed board didn't have PCI Express on the SoC. It was just the memory controller.
Right.
Like, that was the primary piece of proprietary IP that was being used.
Right.
If you had the expansion board, like, that's what brought in the PCI Express.
Right.
And that was from Microsemi/Microchip.
Yeah.
And they were a lot more open about how to deal with that stuff, which was good. But the newer board is not using that IP. It's using very different stuff, and it took them a while to get the same thing. They had to go through the whole process of like, okay, what can we make available? How can we make the zero-stage bootloader as small as possible? And then hopefully get enough in that we can just go straight from here to OpenSBI and U-boot, and then move on with life.
So does the Unmatched use U-boot SPL or now?
I think it can. I'll have to go double check.
At least in Ubuntu it does, yes.
Oh, okay.
Yeah.
Cool.
I don't think it supported it at launch, but I think it came across pretty quickly thereafter because enough of the stuff was open. I think they were still using the BBL initially, and then but that code was open, so people could be like, aha, and then merge it into U-boot.
Okay, that's good.
And if you look into the Vision 5 board, you also have all those first stages open everything that's loaded after the boot ROM is available up as open source.
Yeah,
but it's separate, right? It's the second boot in DDR init, right?
I mean, if you can completely mess up the SPI and everything that is in the SPI, you have source for.
Yeah, so right, it's source, but it's not U-boot, right? SPL. Because it's the same, right, as last year, right? So it's there's two programs, right? There's second boot, which is ironically second boot is what I think most people think of as the first boot, right? And then there's DDR init. And then the source for both of those programs is available. But it's not U-boot SPL, which would be I guess the ideal situation.
Yeah, I mean,
yes,
it's hard, like getting the stuff into U-boot SPL, because the way that works is the only thing you have available to you is L1 cache. So you have to make all of it function in L1 cache with no peripherals and no paging.
Right.
So like it's hard, and that's why a lot of people write their own first stage bootloaders to get to the point where, okay, now the DDR is initialized and we can talk to stuff. Depending on how your boot device functions, like you may not be able to talk to that. Like your SPI device may be connected to something else on the SOC that isn't readily available without another level of initialization. And so you have to run some code to get all of that up and running, which again, also has to operate only in L1 cache.
But my expectation would not be that the future is really U-boot SPL. If you look into the ARM world, that you have TFA, which is responsible for loading main U-boot as BL33.
Yeah, I mean, depending on the vendor in the ARM world, so like Rockchip still uses their own bootloader system, which like by the time you get to U-boot, you're on like the 5th bootloader in their environment.
So you're saying that the trusted firmware is the thing that would it would be in I forget the different levels, but they would be in the EL level that
it would be
like the most privileged, and then it would load U-boot in like the appropriate level.
TFA is running in EL3 and in the ARM world, so this would be M mode, and we need some software in M mode that will start Linux and that will start some trusted application. At some point we will need something like Opti or other trusted code,
and that is being worked on. So like I'm excited to see where that's going to go, and I'm hoping that is going to, because I think they're working with OpenTitan. So I'm hoping that stuff will kind of like flow up into the U-boots and things like that, so that like that ecosystem can be cohesive and work. But yeah, like there's a lot that needs to happen here. I'm really hoping that we don't have the situation where you have what I would refer to as like the hacker friendly environment, which is, you know, U-boot and no trust. And then you have the trusted environment, which just goes straight to EDK2 because, oh God, like that's just a mess.
EDK2 is fine, but the problem is that nearly nobody's writing open source drivers for it.
No,
I mean, if you look into the EDK2 platform repository, there are very few boards on it. From ARM, for ARM boards, I have a Macchiato bin. That's nice. That runs on EDK2, I think the Unleashed was also ported to EDK2.
Yes, no PCI Express, but yes.
So,
and the reason why I say the EDK2 stuff is a mess is because nobody really uses the upstream EDK2. Everybody uses a downstream build, most commonly American Megatrends. And AMI has shown no interest in the RISC-V ecosystem at this point. And they also don't push any of their code changes back upstream. This is also a huge problem because there's a lot of security bug fixes in EDK2 that don't exist in any of the downstream AMI, Phoenix BIOS, Dell, HPE releases, because they forked that code a long time ago.
Yeah, but when I think about RISC-V boards trying to move closer to the server world, then I would guess you would also have some ADK2 based stuff in it. And the nice or where you really could make use of it is, for instance, to get video running at the boot stage. In ADK2 with ARM, it's easy. So if you can emulate, you can run the x86 ROMs via emulation that is a module inside ADK2.
Yes. So right, that
or you can completely replace, of course,
yeah,
the IROM. That's the other method.
Yes, and like it would be nice. I mean, part of the concern I have with EDK2 is like you're absolutely right. Like for the boards that are supported, it does just work. But again, like the process of getting the Sci-Fi Unleashed on EDK2 was, I think, a 3-year effort from a team of engineers at HPE to get all of that stuff done. And they have since moved on and have done nothing on the Unmatched.
Yeah,
I'm not saying they need to, but like it's hard.
If you follow what patches are created, look at the developers of Ventana. They are working on getting UCB for RISC-V into EDK2.
Yeah.
They have worked on QEMU support as a RISC-V platform in EDK2.
Mm-hmm.
But not all of this is upstreamed yet.
Yeah.
And they were also the ones that were pushing for having an additional protocol inside U-boot and in future in EDK2 to pass a boot hard ID instead of using the device tree, passing it via protocol. So, I mean, companies that are interested in the server world, I guess they also think of something that like EDK2 or AMI or whomever who will create a full Uefi implementation. And I guess this is where the server world for RISC-V is going to end up.
I mean, possibly. We'll see. There's kind of like the big problem in the server world right now is that the server world is tired of being beholden to AMI because like the issue with the AMI BIOS is like they not only do they make the BIOS, but they also make the software for the BMCs, so the IPMI controllers and the protocols between that, the system firmware and the BMC firmware are entirely proprietary. Now, the funny part is everybody sits there and goes, oh, there's DMTF specifications for open ways of replacing that communication. I was like, yes, and the only thing that supports it is OpenBMC and EDK2. So unless your platform supports EDK2, and even then you get a small subset of the features that should be available. You basically can use the BMC to replace the firmware on the host and vice versa. And that's basically it at the moment. So there's a tremendous amount of work that needs to be done to make that open. There are some organizations that are working on this in larger environments. Meta being one of them. They're big supporters of OpenBMC, which isn't surprising. The project came out of them because they're tired of being beholden to this, mainly because when they want to make changes to hardware, they want to support new hardware. The only thing they can do right now is call AMI, and AMI tells them to go pound sand, or that'll be $150 million, and then we'll think about it. So it's tough. It may happen that way. It may not. The other part of it is like, a lot of the reason why all of the video stuff is important is because a certain operating system requires having a video console to install. Linux doesn't. So, and there's a lot of work happening from folks like Oxide who are like, maybe we don't need to think about that anymore. Maybe we can start moving back towards what we had before of a serial port is enough if we can have a better way of accessing it than just a serial port and kind of go from there. So it'll be interesting to see how it works.
It depends on what you are running. I mean, if you take an NVIDIA DPU, which is also booting Linux inside via Uefi,
yeah,
then of course it probably doesn't have a video out.
Yeah, exactly. Like,
Or an IoT device will not have video out.
yeah, IoT devices won't have video out. So like having the entire trusted tool chain jump immediately to EDK2 doesn't necessarily make sense in IoT devices, because the smallest build I've seen of EDK2 requires like a gigabit size flash device, and like that's just not cost effective.
So EDK2 requires something like 2 megabytes instead of U-boot requiring 1 megabyte.
Yeah.
But,
but
you can run it with serial only. You don't need video for EDK2.
Do you see long-term, like Canonical would prefer to have something like EDK2 running on RISC-V hardware?
I think it would be great to have. I mean, if we get a board like the Unmatched, where we can plug a normal graphics card in, my preferred solution would be EDK2 with the emulation module on it, so that we can run the Uefi graphical output protocol that comes with the graphics card.
Okay.
Yeah.
I mean, so we have these startups, Revos and Ventana, that are seemingly making server hardware. So is, from a distro's perspective, what's the optimal situation for server hardware like that to run EDK2?
I think if I have such a board at home, I would like to have some video during boot time.
Yeah,
that's the important thing. If you have a GPU that's integrated into the SoC, of course, you will need some U-boot specific driver, maybe. That's a good solution. I mean, even on a Banana Pi, you can get video output during U-boot.
Oh, so U-boot can do video out if you on some platforms. Okay.
It can do some. So like the trick with that is the driver support inside of U-boot for video out is very small, and there is not a terminal emulator. So you can basically throw up an image. You can copy stuff into a frame buffer, and it will show you that. So you get like a splash screen, but that's basically it.
No, you get the full console output.
On what consoles? Like I've been looking into that.
The frame buffer is shown on HDMI, and there's a driver that writes the letters into the frame buffer.
For which frame buffer though?
Yeah, I mean, you need a frame buffer driver inside U-boot with HDMI output, and then you will get a normal console. You just plug in your HDMI monitor, you plug in your USB keyboard, and you use it. No need
so like I've been trying to get something like that working on, like, part of the reason I have an exceptionally old Radeon card in my Sci-Fi.
There will not be a frame buffer driver for it. But if you take a Banana Pi, for instance, one of those very old boards, it has a video, or the Zanxi boards have video drivers. Just take one of those all window SoCs, H6 or whatever. They all come with a driver. You can also have LCD output out of U-boot if you prefer, if you have an LCD connected.
So part of the reason I put that older card in is because there is a driver for it in U-boot, but all it lets you do is just put a splash screen.
Then something is missing in your configuration. Because if there's a frame buffer, U-boot can write letters to it. You even can use TrueType force in U-boot.
I'm going to have to go, like, yeah, I'll have to go dig around and see what I can find to make that work, because that is ideally what I want.
Yeah, and that's why I was saying I would prefer EDK2, because there we wouldn't have to worry about the driver, because a PCIe card comes with a driver if we can emulate it on RISC-V. It will come with an x86.
Right. Yeah, it comes with an x86 COF, and then you've got to emulate that inside of
and Alexander, what was his name? Alexander Graf and Art Wiesövel have been worked up something that in the ARM world just uses part of the QEMU code
right
to do the emulation, and that works fine. So an Uefi program jumps into the graphical output protocol, which is emulated, and if that calls back into the EDK2, this is also correctly translated.
Is that a UEFI protocol or is that a ACPI thing?
No, it's
in
a
the
UEFI thing.
Uefi world, there is a protocol called graphical output protocol. And this is both implemented in U-boot and is implemented in EDK2. But of course, in U-boot, it requires that there's a frame buffer driver beneath it.
Right.
Ah, okay.
Graphical output protocol, I think it's called. Oh, no, graphics?
Yeah.
Okay.
Graphics output, GOP.
Yeah, I just saw that. Okay, interesting. I didn't know that that was the thing you could do. I mean, not with U-boot.
Yeah, there's a lot of stuff in U-boot that is not well documented. Like, that's the other part of the problem.
Yeah, but if you would simply want to experiment with a frame buffer, this output to frame buffer, just compile the sandbox def config. And if you call U-boot with the right parameters, it will use SDL to show the frame buffer output.
So the EFI frame buffer in U-boot, I guess, is using this video protocol.
Yeah.
Graphics output protocol. So I only recently really started looking at UEFI in the last couple of years because of RISC-V mainly, but a protocol in UEFI is essentially kind of like a calling convention, right? I mean, it's kind of like, I think of it like as a function instead of like, it doesn't seem like a network protocol like what I normally think of a protocol.
A protocol is like an interface in Java.
Okay.
And this interface can contain constants, it can contain structures, it can contain method, essentially what you would call a method, which is implemented as a pointer to a C function, essentially.
Okay.
So the Uefi protocol is transferred as a structure, but essentially, if you abstract it from how it's implemented, you can say it's just an interface.
The thing that I found helped me, Drew, in understanding a lot of this, EDK2 is not just a bootloader. It's really a ring 0 hypervisor that runs multiple operating systems, two of which come from itself, and the other one is the one that you actually want to run.
But part of it, right, is, I guess, you know, until a couple of years ago, I conflated UEFI and ACPI to the same thing, and now obviously those are separate things. And
completely separate.
UEFI can do some. UEFI supports some of the. U-boot supports some of the UEFI protocols, but
yes,
EDK2 I guess supports all of them.
EDK2 is the reference implementation.
Okay.
So the genesis of EDK2 was that it was originally called Tyanocore, which is the thing that Intel threw over the fence and made open source when they were trying to make EFI and UEFI more open standards. EFI was originally a partnership between, I'm probably going to forget some of the companies that were in there, but it was Microsoft, Intel, SGI, Sun Microsystems, HPE, and some other Unix companies that don't exist anymore. So it has a lot of weird stuff in it because this was all basically designed during the hardware wars of the 90s and then didn't actually come to fruition until the mid 2000s.
So
and at that point, the only game in town was Intel.
Are the bytecode drivers, is that part of UEFI services then? How on like PCs, sometimes you might have these drivers that are, I wasn't sure. So ACPI is tables, right? So does ACPI also have things that it does, or is it just description tables?
It's basically just description tables.
Okay, so the thing, like I've heard, like, you know, you can have, I guess in your BIOS would have like drivers for things are, which I heard, like my understanding was like they were like bytecode drivers.
Yes,
that's UEFI then. That's
so UEFI supports two different formats for drivers inside of UEFI to bring up hardware. One of them is a UEFI specific universal bytecode, and the other one is native for that platform. The universal bytecode is dead. Intel apparently outsourced that to a contractor. There was never a specification made available for it. The GNU team apparently looked at the specification and ran away screaming, and it was never implemented in GCC. There was a free compiler available from Intel's website for the EFI bytecode, but it disappeared 15 years ago, probably because the contract that Intel had with the third party that they made it with ended and nobody wanted to support it. The other problem was no hardware manufacturer used it. Everyone wrote their stuff for x86 only. And that was the major problem. So I have an old LeMaker cello board that has the AMD Seattle sock on it. And the funny part is the MAC addresses on those boards that I have are all zeros, because the tool from Realtek to implement the MAC addresses on the OTP inside of the PHYs is only available as x86 EFI programs. So there's no way to run it in EDK2 on those platforms. Supposedly there is now, but like I can't get the tools and it doesn't matter. So this is why, as Heinrich was talking about, there was a team at Lenaro that worked on building a x86 COF emulator inside of EFI so that you could run the x86 drivers that are packaged on the peripherals in order to bring them up inside of EDK2 on ARM64. It is not universal, so like we don't get that for free in the RISC-V world. There's a lot of work that needs to be done to get that to happen, but it could happen.
So it kind of, I guess it depends on what Ventana or Revos or these RISC-V server makers will, how they'll make their systems, right? Whether or not,
well,
hopefully this won't be needed.
No, it will be needed. Like
the
hardware manufacturers are most likely not going to ship RISC-V bytecode on their cards for EFI.
Oh, so you mean like a Mellanox network card, that sort of thing?
A Mellanox network card or an NVIDIA or an AMD graphics card or an Intel NIC, like those PCI Express devices have a section of their flash memory that have drivers in it that are loaded by EFI in order to enable things like universal video display and GOP, or the universal network interface. And like there's a lot of stuff like that. That's how you get like all of your SATA and your NVMe and things like that. Newer stuff, there are generic drivers that will work with any hardware implementation. NVMe is a great example of this. But you may still need to have a specific driver for, say, your PCI Express readout.
Newer cards would have that, or newer
newer platforms. So the point is like, there is one NVMe driver. It's in EDK2. It talks to all NVMe devices, assuming that your PCI Express bus works. So there may be a driver in your chipset for your PCI Express bus. There is not a universal driver that everything can use for, say, network cards, but there is for USB 3. Hopefully there will be one for USB 4 as well. We don't know yet. But like things like that. So some of the older stuff, like every SCSI controller had its own driver. Most of the network cards have their own drivers. You mentioned Mellanox. Here's a great example. Mellanox supports ARM on their network cards, but they don't ship the ARM firmware on their cards by default. You have to put it in an x86 system and run a command line tool to add it. They support it and they ship it, and it's EFI trusted and the whole 9 yards. They just don't put it on their cards by default.
Yeah, but for at least for the Mellanox cards, I can confirm that they are running on the unmatched boards. So if they are not available on the at the boot stage, that's not a problem. But
the Linux kernel drivers will pick it up. And then this is the other fun part of it, is like One of the things that weirdly is not abstracted in EDK2 is I2C and SM bus. Like that is all absolutely platform dependent code in every environment, which is weird because like that's how you talk to the TPM modules and all that fun stuff. And so like, I don't know why that abstraction is missing, but it is.
Yeah. But at least the TPM protocol is existing. So if your Uefi, if for instance grub wants to talk to the TPM, then there's a protocol for it, and that's implemented both in U-boot and in EDK2.
Right.
So is the role for U-boot here? It's really for would be for RISC-V systems that don't have enough memory to fit EDK2. Would that really be the main?
I would say it's that, and it's also for people who don't want to spend, people in organizations that don't want to spend the time becoming experts in EDK2 to support their platform.
Yeah, I mean, there's a lot more IP supported in U-boot than is supported in EDK2. Yeah. So and this simply means it's much easier to bring up a board in U-boot reusing existing drivers than is to bring up something on EDK2.
Yeah, EDK2 is GPL2 based, so you can basically copy drivers out of the kernel, whereas EDK2 is FreeBSD license, is BSD licensed, so you can't bring any of the drivers from the Linux kernel with you.
So it seems like, I mean, the thing I've understood is that for the server market, like enterprise distros would expect there to be EDK2. So would that seem to be probably this? It's going to be the same thing with RISC-V then, like that. I mean, the expectation of canonical would be that like a server.
Essentially, Ventana is driving to use Uefi, and so they obviously are expecting that the server market requires it.
Yeah.
So I mean, that's one of the things that is it's kind of a chicken and the egg. Like the reason why the enterprise distributions on the ARM world all required this is because they were like, well, it's not an enterprise platform unless we can install Windows on it. We can't install Windows with anything other than EDK2, so we have to have EDK2 support. And that's not true. Like that's a self-licking ice cream cone. So maybe, I mean, it's one of those things where I don't want to put words in your mouth, Heinrich, and I definitely don't want to put words in your employer's mouth, but my belief is that the enterprise distributions and the large distributions in general, so I'm even going to include like the Debians and things like that, as long as there is a sane, uniform way to boot a kernel and get install media on the system, I don't think anyone cares. There's a lot of work that has to get into that. But if you can put an installer on a USB stick, plug it into a machine, and it will work, that's really what everybody wants. But getting to that point is hard.
an hour ago, I told you that we have a server installed image, and it runs on the unmatched board. Yep. And the same is true for in the ARM world too. So, I mean, there is no difference between a desktop and a server OS in Ubuntu. It's a different collection of packages that you install, but it's the same operating system.
Same operating system, right.
The real big difference comes when you look into Ubuntu Core, where everything is packaged as a snap.
Yeah.
So that is really different, but that will also boot on U-boot. And for Debian, it's also true. There is no difference between server and desktop, except for packages being installed.
Yep.
And
so with these instructions, is this a server installed because it doesn't have a graphical environment, or is that the distinction here?
Yeah.
No, the server installed. What we had before was, first of all, we had pre-installed images. Plug in the SD card, and it simply boots without installation process. The image that we produced here will get you into a menu where you set up what's the system name, what is your proxy, on which drive do you want to install. All this is in here, but it will install none of what, no desktop at all. And,
Okay, so this is like a real install, like what we think of. Okay.
Yeah, the contrast to Debian is that we have different installers for desktop and server. And I mean, in Debian, you just select, do I want KDE, do I want GNOME, or do I want nothing of both? And unfortunately here at Canonical, somebody decided we have one way to install servers and one way to install desktops.
Yeah.
Okay, but this is, I guess, this is a real installer,
Yep.
which is like, I think the only time I've had an installer on a single board computer is with the Minnow board. So this is like that, right? Where it's actually what we're launching here in EFI is an installer, right? Eventually.
Yeah.
Yes, you just with grub, you start a kernel with an init.rd, and that starts then the Go code, because the whole installer is written in Go.
Okay. Well, this would be really natural then for, I mean, other than these few instructions here that are kind of board specific, it would be pretty natural for any Linux administrator then, right?
Yeah, the only, I mean, if you have used QEMU, QEMU currently has under RISC-V the problem that it cannot store Uefi variables at all, because there's no flash for it that is emulated. And U-boot can have Uefi variables, but you have to set them inside U-boot. You cannot set them from Linux.
Okay.
So this is what is making this problematic. On the restart after the installation, you have to take care of the Uefi variables manually.
So it's possible for, like, on Sci-Fi's next board, if they wanted to, they could make it so you wouldn't even have to do these commands, and it would just jump into the installer.
So to give you an example, like I talked about how I had Haiku working on my Sci-Fi board. Like that's basically how that worked for me. I went and got the Haiku install image. I put it on a USB device. I plugged it into the system. It booted. It detected the EFI bootloader on the USB device, and it launched into the installer. Like it was great. It was the world that I wish it was. So now the trick is getting all of the pieces in the appropriate stuff. So as Heinrich was talking about, like there's the device tree fix-ups and things like that that have to happen before Grub comes up. And that's the thing that needs to be fixed inside of Grub, because we should be able to tell Grub, here is a device tree, and everything be okay. But right now, that's currently not working.
That is what was, at least in Ubuntu, it's working. That we are calling back into U-boot to do the fix-ups. And for the unmatched board, you would simply plug in the SD card, and it will boot up into the installer directly, because we have put the U-boot for the unmatched board onto the installer image. But this will probably not work in the future. I mean, in the future, we expect to have different boards, and each board needs a different U-boot on the SD card for booting. So
right. So in my version of a perfect world, what would happen in this case is the boot ROM that comes from the manufacturer has the device tree and U-boot on it. Like, ideally, that's where we would be.
Yes, that's the Vision 5 board. That's the Vision 5 board has everything in SPI.
Yeah.
And on the unmatched board, you could also install U-boot into the SPI flash and forget about it.
Yep. And I think that's, like, for me, that is the world I want, because then I think we're getting closer to the path where everything can just kind of work. And if you need to upgrade the U-boot, that's fine. If you want to use U-boot it doesn't also have to be U-boot. Like it can be EDK2 if you want to have that. But that's where, like, to me, that's where we should be going. That's the standard we should be looking for, rather than having everybody reinvent the bootloader problem for each one of their boards.
Oh, Heinrich, before you leave, is this a good time? Because I was wondering for people in Europe, like if earlier is better, or like someone was saying like later would be better because it's after like dinner time, but I was wondering what you think.
For me, it's fine. I
Okay.
just didn't make it to the previous meetings.
Okay. Okay, cool. I mean, this has actually been a pretty good turnout. There'd been a few ones in the last few months that were pretty low attended, but yeah, I mean, this was good today. So definitely thanks for joining.
Yeah. And Heinrich, thank you for all the information. Like this has been great. I really appreciate it. I'll go do some more research, see what I can come up with, and report back in a month and see where things are.
What are you working on, or for which company are you working, Carl?
I'm working for myself. So I currently have my own company. My company is not part of the RISC-V Foundation yet, mainly because I don't have enough money to pay for it. But I am building a hosting platform for single board computers. So basically think EC2, only instead of it being a bunch of VMs, it's a bunch of Raspberry Pis and or Vision 5s and or things like that available as an infrastructure as a service offering. So once I actually get the point where I'm generating enough money that I can write the check to the RISC-V International, I will, but I'm not there yet.
And essentially, that's what we are trying to do with our MAS product. So this is Metal as a service, which we have as a product, but I have no clue what the licensing cost is, whether it's affordable.
It's expensive. But it's also like I'm providing all the hosting for it as well. So it's basically like think a Linode or a DigitalOcean or an Amazon EC2, and like I take care of all the hardware problems and the storage and all of that fun stuff, and you just get an SSH login to a box. So.
Yeah, Drew, this is a page that was a product I was referring to. That is
the MAS?
Yep. Yes, so this is if you want to have Metal as a service. And I mean, last week I needed something running on Power 9, and I went into the MAS cluster that we have with Power 5 hardware and simply said, okay, please install me the newest Ubuntu on a naked server and let me log in.
So it's just, I mean, it's essentially like, well, back a long time ago when I used to be a Unix admin, like I guess all servers were like this, where I mean, you have remote management, but it's everything down to the remote management console you control, right? So
right.
Okay.
Yeah. I used to work at Packet, like that was the large hosting company I worked with before, where we bought a lot of ARM servers. We did the same thing, like, but instead of it being a small SBC, like it was a full Ampere box or a full Qualcomm Cintiq or a full Cavium ThunderX, or a full Dell PowerEdge 3515 or whatever, same sort of thing. I'm just bringing that down to a different form factor, and part of the reason for that is as a way to bring new technologies into the environment. So like, as we were pointing out, it's gonna be a long time before there's RISC-V servers, but we can get RISC-V boards now. So as soon as I can get my hands on enough of them, and I'm building the control hardware to manage of turning them on and off and making the serial consoles available and things like that, then yeah, I'm going to make them available and I'm going to let people use them and they can do whatever they want with. The other part of it is like getting something that makes sense for a price performance point. Yeah, but right now the 8 gig Raspberry.
What this MAS does is simply causes the server to PXE boot, and via PXE boot we get the installer image onto available, and then boot from the installer image, run through a complete installation that is automated to some degree, and then you get the boot log, the installation log, and you get the IP address which you use for your SSH connection.
Yeah. Is there some is there some virtualization, or is this actually like a machine?
No, this is the OS on the machine.
Metal.
Yeah.
But doesn't that mean that there's just, you'd have to have like a bunch of physical servers and some of them wouldn't be used?
Yep.
Some of the
Yep.
time. Okay.
Yep.
This is how I remember data centers being.
Yep.
Back in the 2000s, like when I was an admin.
Yeah, but you can really set it up as a self-service. And
Okay.
I mean, if you go to a hoster, like I was working together, you having a private machine at Host Europe, it would be just the same thing. You go into an app interface, and 2 hours later you have your machine.
You can get those sorts of things from Equinix Metal. You can get them from Hetzner. You can get them from 1&1. Like they still exist.
But the downside, I guess, for doing that is then you have to figure out what ratio of like on-demand capacity you have, right? Because
I mean, it's not significantly different than like using instances from Google Cloud or AWS or OCI.
No, I mean the provider, right? Because you have to like with like AWS, right? Like there's a layer underneath that versus here.
Yeah,
it's like
AWS can over provision their hardware and we can't. But but yes. I mean, that's a problem for every hoster. So it doesn't matter if you're a big cloud provider or if you're a small guy like me who's doing it on bare metal. Capacity management is always the hard problem.
Yeah, but essentially, you would try to separate out as much as possible. I mean, you will put the drives on iSCSI or NVMe
exactly.
over fiber, and this way it's only a bit of software on the SD card that has to be on your Raspberry, and that's it.
SD cards are miserable. So like, that's part of the solution of this is like, I'm building stuff so that the systems boot and then they immediately attach to an iSCSI device, and then they use Lux encryption for all of the data that's on said iSCSI device. So all the traffic over the network is encrypted and all the data that's on the disk is encrypted, and I can't even decrypt it. It's things like that.
What I've been doing is really, or why I started working on U-Boot was really to get iPXE running. And
nice.
Unfortunately, it doesn't exist for RISC-V yet, but on ARM, this is what I do also on my test machines. Just boot them directly from via iPXE from an iSCSI drive.
Yeah, I want to do the extra layer of encryption and eventually supporting trusted boot on these platforms. So there's a little extra work that needs to be done there for me. But otherwise, it's pretty similar. So see how it goes.
Okay.
Cool.
Thanks, everybody. Have a great rest of your day.
All right.
Have a nice day. Goodbye.
Bye.
Okay.